can hear my beautiful voice.
I'd rather hear his voice explain it.
See, good answer. Like Family Feud. Good answer. Good answer,
And
Ashley.
then you'll get into hear a whole different conversation thanks to Austin.
Oh yeah, that was a good one.
What'd
I do?
That conversation we had yesterday while I was recording.
Yeah, that was great.
Whatever. Once again, I don't say anything in the recording that I wouldn't say to anyone else. I know.
So are we doing page 66?
66 today. And 67, but they won't take very long. Okay, 66. We're doing 67. They won't take very long. But we're going to look at 66 first, and I'll give you some time to start the homework. Yeah, it's basically the same thing we did Monday. So what we're looking at on 66, it's going to be basically the same idea we did Monday, except we are adding one part to it. So what we're going to look for is we are going to want to know the x-intercept. So I'm going to look for the x-intercepts of the parabola, which we've talked about intercepts before. The x-intercept is going to be where? We did it with lines. What happens at the x-axis? Something with the x-axis. No? So what's the y-intercept? Where the line does what? Crosses the y-axis. So my x-intercepts are going to be where the parabola. So where the parabola, because we are talking about quadratic, so instead of lines, I will have a parabola. So where the parabola crosses or touches the x-axis. And you treat it the exact same way we did when we were talking about x-intercept with lines. It is where the parabola crosses or touches the x-axis. Now let's think about how many x-intercepts I can possibly have. So if we think about drawing a picture, here's my x and y axis. Okay, how can I have one x-intercept? It only crosses at one point, and that point has to be the vertex. So if I only have one x-intercept, that x-intercept has to be the vertex. That means it's going to hit at the vertex. It only crosses, it doesn't actually cross the x-axis, it only touches the x-axis at one spot. What's going to happen if the point where it touches is not the x-axis? Then there's going to be how many? If I start moving this down, or up, let's start moving this down. If I start moving this down, I'm always going to have how many intercepts? 2. So if I move it down, something like this, could have 2. So this is how I would, normally you're going to have 2 x-intercepts, because it will look something like this. So here's 1, if it touches at the vertex. Here's 2, cross on the left and right. How could I have 0? It's above or below. So it could either be like something like that or above it, so it doesn't cross at all. Could I have 3 x-intercepts? If I think about a parabola, would it be possible to have 3 x-intercepts? No, because it goes up. It doesn't come back down. So it's going to either cross twice, once, or none, like this. So you're either going to have 1 x-intercept, 2 x-intercepts, which will usually be the case, or no x-intercepts. Okay? Now, don't make this harder than it is. How do I find the x-intercepts? We did this with lines. If I'm looking for any point on the x-axis, what do I know about the y value for any point on the x-axis? The y value is always what? Yes? 0. So, just like we did with lines, we're going to plug 0 in for y. So nothing is really different. We do it the exact same way, but we are plugging 0 in for y. Nate? Just wait, it's when convenient, so remind me it's up here. Okay, so let's look at finding a couple x-intercepts. Let's look at this one. We have y equals x squared plus 4x plus 4. And I want to find the x-intercepts of this. It's going to say find the x-intercepts and then sketch a graph. Sketching a graph is just what we did on Monday, so that's nothing different. But the x-intercepts kind of help you with sketching the graph. So, if I want to find the x-intercept, I plug 0 in for what? Y. So plug 0 in for y. And this is, sometimes I usually don't pick warm-ups randomly. I usually do it because it's going to be something we're going to see. This is why I chose the warm-ups I did today, is because what you're basically doing is you're plugging 0 where y is, and you're solving this quadratic equation, like we did in Unit 3 and 4. Or Unit, I forget what unit was, but last unit. So if I solve this, well, it's a trinomial with a 1 in front, so I would try to factor this. How could I start trying to set this up to factor? 2 parentheses, like we did some yesterday, x is in front. They're both positive numbers, so I know my numbers are both going to be positive. 2 numbers that multiply to give me 4 and add to give me 4, so 2 and 2. So as I go to find the x-intercepts, just like we did on the warm-up, set it equal to 0. Now I only have to worry about one of them because they're both the same. So my x-intercept is -2. So like I said, this is really nothing new. We've done this before, but we're just kind of putting it as x-intercepts. So as I graph this just kind of adds another element to your graph. As I graph this, I know it's going to be a parabola because it's x squared. So I'm going to go left 2 and put a point because I know that that's the x-intercepts. So it has to either cross there or just hit there. Now, like I talked about earlier, since there's only one x-intercept, what do I know about that x-intercept? Look at the picture up here. If there's only one x-intercept, I know the x-intercept has to be the what of the parabola? The vertex. So I'm thinking, since I only got one, when I check the other ways, like we did on Monday, I should be getting -2, 0 as the vertex, but we'll just double check. So now we need to graph this. I only have 1 point, but now we need to graph this. So let's graph this using what we did Monday. Let me pull this out because my binder is. So let's use the 3 steps we used Monday to graph this. So the first step is going to be finding the axis of symmetry.
Can't you just put the y-intercept on there and then plug that?
Yeah, you could for this one actually. I'm going to go through the steps, but yeah, that's a good point. Since I know it's the vertex, we know that my y-intercept, well, what's the y-intercept been?
What?
What's the y-intercept? 1, 2, 3, 4. Put a point. Yeah, you can save yourself time actually. Yep. So I know since that only is going to work when you get one x-intercept and you know it's the vertex. Otherwise you'll have to go through the work. But it'll work, go through the steps. My axis of symmetry always goes through the vertex. And so where would another point be?
1 or 2 over from
2 left.
2 left.
And there's your parabola. Yep, that's fine. I would accept that. So yeah, if you get 1 point, you know that's your vertex. Find your y-intercept, which is always your c value, and you can do it like that. Yep, so that does save yourself some time. Okay, good. I didn't think of that. Look at you go, Ben. So proud of you. Okay, let's look at a couple more real quick. Let's look at another one. Let's look at one like... let's look at one like... Let's look at one like this one. Let's look at example 2. Okay, let's look at this one. So here's a quadratic. It's x squared. If I graph this, this will be a parabola. And the directions will ask for the x-intercept. So how do I always find the x-intercept? 0 in for y, which doesn't really change anything. So now I need to solve this for x. So I'm thinking this is quadratic. So we can try to factor. Will this factor? I mean, we could do negative 2 times negative 73 and blah, 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 do the long way, but we're not going to. Let's just start using the what? Quadratic formula. So let's just try the quadratic formula on this. Negative b, so negative 24, plus or minus the square root of negative 24 squared, minus 4 times a times c, all over 2 times negative 2. So if you get to one where it's not going to factor nicely, most of the ones on your homework will factor. But if you get to one where it's going to be kind of hard to factor, or you just don't want to do it, or whatever, or it won't factor, you can use quadratics. So negative b plus or minus the square root of negative 24 squared, minus 4 times negative 2 times negative 73. Let's go through and simplify. 24 plus or minus the square root 24 squared. What is it? Okay, what's negative 4 times negative 2? 8 times negative 73. 584 over negative 4. Combine under the radical, so it's going to be 24 plus or minus the square root of negative 8. What do we notice? Square root of a negative number, which means what? No solution. So like we said when we did quadratics, if you end up getting the square root of a negative, that is no solution, which tells me how many x-intercepts do I have? None. Which tells me that my parabola is going to be either above the x-axis or below the x-axis, because I get no solution when I try to find the x-intercepts. But we can still graph it real quick.
We're going to have to graph it on the homework.
Yep.
Is that our last example?
Yeah.
Am I sitting this up right now?
No, because f of x plus delta x was where our x is. It gets plugged in for x. You have two x's. F of x plus delta x minus f of x over delta x.
Oh, so I don't have to have the bottom part?
You do, but it's just going to be x plus delta x, because
okay.
it just gets placed in there.
And then would I multiply them out first, or would I find a common denominator?
I would get common denominators. Okay, so let's go ahead and graph this. I know, since I have no x-intercepts, it's not going to cross or touch the x-axis. So as we graph this, we should see that. Okay, then. So first step, x equals negative b over 2a. This is just review from Monday, but we'll just go through it since it seems like some of us need a refresher. Negative b, what's b? So negative 24 over 2 times negative 2. Check your negatives. Yep, because it's a negative b and b is a negative 24. So 24 over negative 4, which is negative 6. Negative 6. Because it's a positive 24 over negative 4. You're good. So my axis of symmetry is negative 6. Let's go ahead and find the vertex, which is ordered pair x comma y. I know x is what? Negative 6. It's always the same as the axis of symmetry because it goes through it. Let's find the let's find the y value. Check your negatives. That is the biggest issue that I am seeing. You guys can plug numbers in. Just be careful. Do not rely on your calculator. Don't just plug in negative 6 squared. Use your head. What is a negative 6 squared? Positive 36 times a negative 2. Negative 72. Negative 24 times negative 6. Positive, do it in a calculator, 144 minus 73, and then just plug it in. Negative 72 plus 144 minus 73. What is it? Negative 72 negative 1.
Yeah.
This is stressful. Negative 72.
Listen.
Just plug it in your calculator. You're good. You can do that. Negative 1. So my y value is negative 1. Negative 6, negative 1. And what's the y-intercept? What's the c value? Negative 73, which we're not going to worry about graphing too much, but we can get a good parabola without it. Okay, so as I look at this, negative 73 is my y-intercept, where we're not going to worry about. Let's graph the vertex. Negative 6, left 6, down 1. It's my vertex. My axis of symmetry through the vertex. Now, I don't have a whole lot of information. Is my parabola opening up or down? Down. Why is it down? Your a, which is the number in front of x squared, is negative, which opens down. Why doesn't it make sense that it's opening down? Down, no, I don't know. Going down, down, like a last weekend. Again. Anyway. I know. Why else is it going down? Do I know it has to be going down? Do I have any x-intercepts? No. So if it was going up, it would hit the x-axis. So it needs to be going down. Okay, so how do I find? I only have 1 point. The y-intercept is way too far down. How do I find another value? Nope. Make a t-chart. So let's plug in another x value and see what y is. So if I plug in another x value, what would be another x value to plug in? 1. I would choose one closer. So let's do a negative 5. Let's try a negative 5. Plug in negative 5. So if I plug in negative 5, I'm going to get negative 2 times 25. What's negative 24 times negative 5? Negative 24 times negative 5? Positive 120 minus 73. And then let's go through negative 50 plus 120 minus 73, which is negative 50 plus 120 minus 73. Negative 3. So if I graph this, negative 5, negative 3, down here somewhere, I have 2 points. How do I get the other point? Left one. Okay. So usually your y-intercept will be able to be reflected, but if not, like we've talked about, you may have to make a t-chart, plug in a point, and then reflect that point. Okay, that's good for this section. So go ahead and put your notes to the side. On the homework,